All right, greetings scholars. Here we're going to be taking a look at chapter 5 in polynomial and rational functions, and we're going to be looking at section 5.1 quadratic functions. So a few learning objectives here. In this section, you will recognize characteristics of parabolas, understand how the graph of a parabola is related to its quadratic function, determine a quadratic function's minimum or maximum value, solve problems involving a quadratic function's minimum or maximum value. So in this example, we're asked to determine the vertex, axis of symmetry, zeros, and y-intercept of the parabola. We do have a vertex formula when it comes to parabolas. All right. So the x-coordinate of a vertex, which is our h, that's going to be our negative b over 2a. Okay. Let me see. Oh, well, I guess since we'll come back to that. Since we have the image, we can just actually look at it, pull it directly from the image. So when x is 3, the corresponding y is what, 1? So our vertex is the ordered pair 3, 1. Okay. The axis of symmetry is going to be the x-coordinate of the vertex. It's going to be x equals 3. The y-intercept is going to be what? Y equals 7 or 0, 7. Okay. Well, the zeros, there are no zeros because it doesn't cross the x-axis. Yeah. Okay. 3, 1. X equals 3. So no zeros. And the ordered pair 0, 7 is the y-intercept. All right, so we have these different forms of a quadratic. A quadratic function is a polynomial function of degree 2. The graph of a quadratic is a parabola. The general form of a quadratic takes on the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The standard form of a quadratic is this f of x equals a times x minus h squared plus k, where a is not equal to 0. The vertex h comma k is located at negative b over 2a. So the h is negative b over 2a, and then the k is going to be f of h, or f of negative b over 2a. When we have our quadratic in standard form, it identifies the vertex also, the h comma k. So given a quadratic function, given the graph of a quadratic, write the equation of the function in general form, so the ax squared plus bx plus c. So it looks like they're using the standard form and then going from the standard form to the general form. Okay. Let's see if we can see this in action. So write an equation for this quadratic function g in figure 7 as a transformation of x squared, and then expand the formula and simplify it to write it in general form. Okay. So we're gonna generate the standard form using transformations of functions, right? In general, the toolkit function or the parent function is where the parabola starts at the origin. So if we track the vertex, right, it looks like the vertex went what, left by 2 and then down by 3. Okay. So if our parent function f of x equals x squared, let me see, to capture going left by 2, we're gonna add 2 on the inside, so f of x plus 2. So that's going to be x plus 2 quantity squared. And then to go down by 3, we subtract 3 on the outside. So f of x plus 2 minus 3. We have this x plus 2 quantity squared minus 3. Okay. That looks like... we might need to... So the only thing that we're missing is our vertical, did we do a vertical stretch or any kind of we need to factor our coefficient a. Okay. So then g of x, I'm just going to tack on this a, right? Because that's our coefficient. That's the only thing we're missing. X plus 2 squared minus 3. And we're trying to figure that out. So I'm just going to choose a few test points, right? When x is 0, y is negative 1. So let's try that one. So we're going to have a times 0 plus 2 squared minus 3. We said the result is negative 1. So that's 4a minus 3 equals negative 1. Add 3 equals 2. Divide by 4, a equals a half, right? Okay, so it looks like our function g of x is 1/2 times x plus 2 squared minus 3. So then we can choose a few test points to make sure it works. So again, when we plug in 0, we should get negative 1. So 2 squared is 4. Half of 4 is 2. 2 minus 3 is negative 1. When x is negative 2, we should get negative 3, and we do. When x is, do we have some other clean points? We could do 2. When x is 2, we should get 5. So 2 plus 2 is 4 squared is 16. 16 divided by 2 is 8. Minus 3 is indeed 5, right? Okay. And write it in a general form. The general form is what? Ax squared plus bx plus c. So basically they're asking us to expand this out. I guess I'll just duplicate this side. And clear. So let me get a copy of this. And we'll just go ahead and expand this guy. So if we FOIL, that's going to become x squared plus 4x plus 4 minus 3 like this. We distribute the 1/2. That's going to be 1/2 x squared plus 2x plus 2 minus 3. So then g of x in general form should take on the form 1/2 x squared plus 2x minus 1. Nope. Okay. All right, I feel like this is okay. So the standard form, let me see. So we can see that the graph is the quadratic function shifted left 2 units and down 3, right? So then I think they got the same a times x plus 2 squared minus 3. And then substituted, they plugged in when x was 0, the corresponding y was 1, so we got a was a half. And then we expanded that to get 1/2 x squared plus 2x minus 1, right? So they essentially did the same steps that we did. Yeah, I think it's okay. The a, again, it just comes from the standard form of a quadratic, right? The h and the k, again, we were tracking the vertex. So we went left 2 and down 3. And then we, the standard form, we do have to try to solve for that a. So given a quadratic in general form, find the vertex, identify a, b, and c, and then we can use the vertex formula to find the x-coordinate of the vertex, which is negative b over 2a. And then once we get that result, we plug it into the original function to find our y. Okay, so find the vertex of this quadratic and then write the quadratic in standard form or vertex form. Okay, so this is given to us in general form, so we can use our vertex formula. Our h is going to be negative b over 2a. Okay, so because our function is given in general form, Our A is 2, our B is -6, and our C is 7. Okay. So then the x coordinate of our vertex, which is h, is going to be negative b. So it's going to be a negative 6 over 2 times our a. Our a is 2. Okay. So that looks like it's a positive 6 over 4, which reduces down to 3 over 2. So then to find our k, we're going to do f of 3 over 2. So then that's going to be a 2 times 3 over 2 squared minus 6 times 3 over 2 plus 7. That's 9 over 4 becomes 9 over 2. 6 divided by 2 is 3 times 3 is 9 plus 7. 9 over 2 is, let's say, 8. That's a 4.5 or 4.5. Minus 2 is 2.5. Which is the same as 5 over 2. Okay. So the standard form of a quadratic takes on the form of f of x equals a times x minus h squared plus k. Now we can plug in a lot of this. So then our f of x, our f of x, I don't think is it the same a? It might be the same a. So we know we have this x minus 3 over 2 squared. Our k we got was 5 over 2. I'm assuming it's the same a from that we had earlier. So, I mean, we could check, like, you know, for instance, when x is 0, the answer should be 7. That's going to be a 9 over 4, 9 over 2. 9 plus 5 is 14 divided by 2, which is going to give us our 7. I'm going to go with this. I got this a from the a that we found earlier. I'm going to go with this. Okay. Ouch. All right, let's see how do we do. So we got the 3 halves for h, 5 halves for k. Okay. The standard form of the quadratic function prior to writing the function then becomes this. One reason we may want to identify the vertex of the parabola is that this point will inform us where the maximum or minimum value of the output occurs, k, and where it occurs, x. Okay, that's fine. Okay, so given the quadratic function, in order to find the domain and range, I'm going to start with this how-to. First, identify the domain of any quadratic function as all real numbers, right? If it's quadratic, in general, the domain of a quadratic is all reals. And then for the range, we look at the a, right? If our a is positive, that means the quadratic opens up and we should have a minimum value, all right? If a is negative, that means the parabola opens downward and we should have a maximum value. Okay, so we'll get this. So find the domain and range of this guy. So again, with it being a quadratic, the domain is going to be all reals. So negative infinity to infinity. The range, notice that the a is -5 is negative, so that means the quadratic opens downward. So we should have a maximum value that occurs at the vertex, right? So if we find the coordinates of the vertex, we'll have our information in order to find the range of this guy. So let's find the vertex. So we're going to use our vertex formula. H equals -b over 2a. Let me clean up that 2. Right? And then so we're given our a is -5, our b is 9, and our c is -1. Okay. So then our h is going to be -b over 2 times our a. Okay, so double negative is positive. So it looks like it's 9 over 10. So then we need to go and find, so that's the x coordinate of our vertex. We can use that to go back and find the y coordinate, which is going to be our k. That's going to be f of 9 over 10. So that's a -5 times 9 over 10 squared plus 9 times 9 over 10 minus 1. I'll keep working over here. So 100 the 5 turns 100 into a 20. So it looks like it's going to be a -81 over 20 plus, now if that's 81 over 10, so then we could say 162 over 20 minus 20 over 20, right? To add fractions, you can use your calculator. To add fractions, we need a common denominator. So now we can just add and subtract the numerators. So that should be 81 minus 20 to give us 61. 61 over 20. I think it's the prime number. All right. So if the parabola opens downward, that means the vertex occurs at a maximum value. So the range being the very bottom to the very top, this 61 over 20 is going to be the very top, and the very bottom is going to be -infinity. So that means our range is going to go from -infinity up to 61 over 20. We use a square bracket because we can include that number, right? It reaches that number, but it doesn't go beyond it. Because again, we want that to be a maximum value. Okay. So with any quadratic function, the domain is all reals. Because a is negative, the parabola opens downward, and we're going to have a maximum value, 61 over 20. Yeah, so -infinity to 61 over 20, the half interval. Okay. So finding the maximum value of a quadratic function, a backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wire of fencing to enclose the 3 sides. She will use a section of the barnyard fence as the 4th side. Okay. Find a formula for the area enclosed by the fence if the side of fencing perpendicular to the existing fence have a length L. A backyard farmer wants to close a rectangular space for a new garden within her fenced backyard. She's purchased 80 feet of wire to enclose 3 sides, and she will use a section of the barnyard fence as the 4th side. Okay. So we'll do the barnyard fencing in brown. And her fencing, so she's going to use part of that fence, the existing fence, and then she's making a rectangular. So I guess I can just go like this. But what I'd like to do, that kind of worked actually. That's good enough. All right. So her fencing, she's doing the 3 sides. So she's going to use a part of the existing fencing, and she's going to make a rectangle with some new fencing. Let me see. A backyard farmer. She has 80 feet. So she has 80 feet of wire to use. Find a formula for the area of fence if the sides of the fencing perpendicular to the existing fence have a length L. Okay. So we're going to let L run from here to here. And I guess we'll let this be W. Okay. So then if we add up the sides, again, we're going to have L on the other side as well. So then if we put those together, 2L plus W is going to equal 80, right? Let's see. So we can say something like the perimeter based on L is going to be does that work out for us? So we can express W. W is going to be what? 80 minus 2L? I feel like something's a little off there though. Here, let's not do this. We're going to keep the first part but not do this. That would be 80 minus 2L. But then it's just going to leave us with 80, right? So, but we can at least get an expression for the area. So say she wants to maximize the area based on the length, right? So that's going to be what? L times W, right? So then that's going to be L times, now W is going to be what, 80 minus 2L? Okay. So then the area based on the length, if we distribute, we get a negative 2, let me clean this up, negative 2L squared plus 80L, right? So notice that this is a quadratic function, right? The leading coefficient is negative, so that means the parabola should, the parabola should open downward. If the parabola opens downward, that means we're going to have a maximum value. It should occur at the vertex. So let's find the vertex. I'm going to kind of work over here for a little bit. Matter of fact, let me shrink all of this down. So just trying to generate some space. And I'm actually going to take some notes over here. So the h coordinate of a vertex should be negative b over 2a. So that's going to be negative 80 over 2 times negative 2. So 4, so it should be 20. So when L is 20, then we can find, so let me see, the vertex of this function occurs when L is 20. Okay, so then we can find the maximum area and we can find the width. All right, so then A of 20, that's going to be what? Negative 2 times 20 squared plus 80 times 20. Okay. 400, so negative 800. Let's do a 1600. 800 feet square, or square feet squared. So that's going to be the maximum area. And that occurs when the length is 20. And if our length is 20, So then the width, right here, let me highlight this. So then the width is going to be 80 minus 2 times 20. That's a 40, so the width should be 40 feet. So find the formula for the area enclosed by the fence. Okay, so the area based on L, and I think we got that. So that's going to be this guy. So that's part A. And then what dimension should she make her garden to maximize the enclosed area? So the area, the dimensions that maximize, let me see. L looks like it needs to be 20 feet and W needs to be 40 feet. I think I was getting stuck earlier because I kept trying to write the perimeter based on L, but they really wanted the area based on L, which is what we did anyway. So I think we got it. And instead of doing my double tick marks, I'm gonna unbox this information. Okay, and I'm gonna shrink this down just a little bit. Okay. Okay, I think this is good. I feel confident about this. Let's look at it. Right, so she has her fencing, and then she has her guarding, L and W. So we know we have only 80 fence available, so we got 2L plus W equals 80. So then we can write W in terms of L, which is what we did. So then the area in terms of L, I think we got the same thing, negative 2L squared plus 80. So since that was quadratic, the parabola opened downward, which means we had a maximum value. The leading coefficient was negative 2, which was negative. So that means the parabola opened downward, which means we had a maximum value that occurred at the vertex. So then we found the coordinates of the vertex. We used the vertex formula, negative b over 2a. So we got that the area, the x coordinate, or L, was 20 from the vertex formula, and then the corresponding area was 800 square feet. So the maximum value of the function is the area of 800 square feet, which occurs when we make L 20. So when the shorter sides are 20 feet, there's 40 feet of fencing left for the longer side to maximize the area. She should enclose the garden so that the two shorter sides have a length of 20 feet and the longer side parallel to the existing fence has a length of 40. All right, so that's exactly what we got. That was interesting. I like that one. Sorry, I kind of stumbled a little bit. I got hung up because I kept trying to write the perimeter in terms of L, and I was like, well, we need some more information. So I just kind of skipped it and just kept going with what naturally flowed for me. Turns out when I went back and read it, it said it wanted the area in terms of L, which is what we ended up doing anyway. So we had it. Let's try this one. So finding maximum revenue. The unit price of an item affects its supply and demand. That is, if the unit price goes up, the demand for the item will usually decrease. For example, a local newspaper currently has 84,000 subscribers at a quarterly charge of $30. Market researchers suggested that if the owners raised the price to $32, they would lose 5,000 subscribers. Assuming that subscriptions are linear related to the price, what price should the newspaper charge for a quarterly subscription to maximize the revenue? Let's see if we can get this one. So if the unit price goes up, the demand goes down. It says that it's linear, so we're going to be working with y equals mx plus b. Okay. A local newspaper currently has 84,000 subscribers at a charge of $30. Right. So let me see. Is the subscribers based on the dollar amount, or is the dollar amount based on subscribers? So it looks like we're taking charge of the price, and we want to see how that affects the subscribers. So it looks like the first piece of information, when we charge $30, we have 84,000 subscribers. Then the research suggests that if we charge $32, we're going to lose 5,000. So that's going to put us at 79,000 subscribers. Okay. To maximize their revenue. It says, assuming that the subscriptions are linearly related to the price, we want to maximize the revenue, the money generated. So we could find the equation of the line through these 2 points. Okay. I'm looking for something quadratic in nature. Assuming the subscription is linear, what price should they charge to maximize the revenue? Okay, well let's start by, I'm still kind of missing, I'm not seeing the whole thing, but let's go ahead and find the equation of the line that's relating the price to the number of subscribers. So it looks like we need the slope. So that's going to be like a y2 minus y1 over x2 minus x1. And I like to label, let's go ahead and say x1 y1, x2 y2. So we said 79,000 minus 84,000 over 32 minus 30. I'll keep working up here. That's a negative 5,000 over 2. So that's a negative 2,500 subscribers per dollar, or subscribers per dollar. So basically what they're saying is that we'll lose 2,500 subscribers for each dollar increase we increase the price. Let me see. So let's see if we can create a revenue function. So the money generated, right? So the revenue, let me see. Is going to be the price of the newspaper times the number of subscribers. Let me think. We're almost there. The unit price, right? As the unit price goes up, the demand will usually go down. There's something that I'm missing here. Times the number of customers. Like if it were free, I feel like, let me see if there's some other information I'm missing. To maximize the revenue, right? So the price they charge for each one. Let me see, at one point we had 32 was the price. So we're trying to generate a revenue function. Let me see. So every dollar increase, for every dollar they increase the price, they lose 25. So let me see. When they let that be 30, the money generated. So the money generated at 30, it was basically 30 times 84. Okay. Something that I'm missing that I'm just not connecting here. Let me see. So we got that slope. That's fine. This tells us that the paper will lose 2,500 subscribers with each dollar they raise in the price. So we can solve for the y-intercept. Y equals mx plus b. Okay. Okay. So the demand. So the revenue. So plus. Okay, so I think the thing that we're missing here is plus b. Right? And I think that the price is the negative 2,500. I mean, the number of subscribers, right? So what we can do is take one of the pieces of information given. Let's see if that works. So when the price is $30, we'll have 84. Does that tell us it? Let me see. Why do I feel like I'm getting? I feel like I'm getting two different. I guess we could just plug in one of them, right? So the revenue, the money generated. Number of subscribers is 84. That's the rate of change of the number of subscribers. Okay, so let me see. So here, X is what, the number of subscribers. The revenue, like if we charge $30 per newspaper times 84 subscribers, we multiply those numbers to get the revenue. Siri, what's 30 times 84,000?
30 times 84,000 is 2,520,000.
That's we're losing that many subscribers for each dollar increase. We know we're trying to solve for B. That price was 30. Yeah, that's still something is off there. I'm gonna have to use this. Let me see. So, so we can solve for y. Let me see. Okay, 84. So Q is that not the revenue? Yeah, that's the revenue. P times Q. Let's see. 84 and 30. So we're like kind of stuck in here. I'm just kind of mixing up like what's what. So first, this guy is the number of subscribers. That's not the revenue. So I think I was trying to make a revenue function. This was, I think it looks more like a demand function. So Q, right? The number of subscribers. So that one was 84. So that was the first thing. Instead of trying to make a revenue, let me see. And that the number of subscribers is going to be, now that one we charged $30. And the rate of change was this negative 2,500. So the only thing we don't know is the y-intercept. So then 75,000. That looks like okay, 75 and 84. Siri, what's 84 plus 75?
84 plus 75 is 159.
So that's our y-intercept. So then the number of subscribers, let me see, is going to be that's negative 2,500. So that's is the number of subscribers is decreasing by 2,500 for each dollar increase in the price. And this is, I guess, X there plus the 159. Okay, let's see if this works. So were we just finding the equation in line through those 2 points? That's all that we were doing, right? We found the slope, and then, yeah, I don't know why I didn't think to just find the equation in line. All we were doing was finding the equation in line through those 2 points. Okay. But I was getting mixed up because I was trying to force it to be the revenue function where it should have been like the number of subscribers, function for the number of subscribers. If we let X be 30, okay. Siri, what's negative 2,500 times 30 plus 159?
Negative 2,500 times 30 plus 159 is negative 74,841.
Something's still off. Because when we plug in $30, we should get 84. Okay, so if we do y equals mx plus b, we got our m. Our x in that case was 30. All right, and our b was 84. I mean, our y was 84. Siri, what's 30 times 2,500?
30 times 2,500 is 75,000.
Siri, what's 84,000 plus 75,000?
84,000 plus 75,000 is 159,000.
Okay. So then when the price is $30, we should get 84. Siri, what's negative 2,500 times 30 plus 159?
Negative 2,500 times 30 plus 159 is negative 74,841.
Siri, what's 75 plus 84?
75 plus 84 is 159.
Why is it off by 10? Let me look at it one more time. We found the slope. I think our slope is good, right? That's a negative 5,000 divided by 2, 2,500. Okay. Trying to solve for our y-intercept. So we add, it should start, oh, well, I guess it would be maximized at 159,000, but this should work and it's not working, and it's kind of irking me. If we lose 5,000, we should be at 79. Siri, what's negative 2,500?
Sorry, I didn't get that. Could you restate the question?
Let me see. 32. Siri, what's negative 2,500 times 32 plus 159?
Negative 2,500 times 32 plus 159 is negative 79,841.
I didn't say it right. 32, right? Siri, what's negative 2,500 times 32 plus 159,000?
Negative 2,500 times 32 plus 159,000 is 79,000.
See, that one checks out. Okay, let me try the 30 again. Siri, what's negative 2,500 times 30 plus 159,000?
Negative 2,500 times 30 plus 159,000 is 84,000.
I think I was just saying it wrong earlier because I was like, these numbers are working out. It's just when I'm checking it, it's not working out. I think whatever I was saying earlier, I just wasn't saying the right thing, or I wasn't articulating. Okay. So now in order to maximize this guy, it looks like that's going to occur when X is 0. If they charge 0. So what price should they charge? Let me see. What price should the newspaper charge for a quarterly subscription to maximize the revenue? $1? This is weird. Let's see. So we got that. We got right here the revenue. Okay, what is Q? Right. So then the revenue is going to be the price times the number. Okay, so Q is the number of subscribers. Okay, So we got an expression for the number of subscribers. Now for our revenue functions, we're going to say the price times the quantity, right? So however much we charge. That's because I was like, I knew we needed a quadratic function. Now we're getting it. So it's here. I think we got it now. Let's clear this guy out. All right. So let's pull. So this Q was a function that describes the number of subscribers. So, okay. So to kind of recap where we are, I think we got it now. This is the information that was given, right? It said that when we charge $30, we'll have 84,000 subscribers. When we charge $32, we have 79,000 subscribers. So what we did, we found the equation of the line through this point, and this gave us the number of subscribers based on the price, right? That's what this is, the number of subscribers based on the price. So then if we want the revenue, and I was getting stuck because I was trying to jump straight to the revenue function. I was like, wait a minute, something's not matching up here. So now that we have the quantity, right? So the revenue is going to be the price per unit times the number of units sold, right? So I think we're there now, because I knew we needed something quadratic in nature. So then our revenue function is going to be the price per unit times the number of subscribers. Okay. Let's paste. Okay. Let's see. And so instead of okay, so I guess we need to put that in terms of P. Let me see here. Tell us based on the price, right? So the X is our price, so that should be in terms of P. Okay, so now we got our quadratic function that we were looking for right here. That's supposed to be a P and a P right here. That's fine. So now and this is a P as well. Yeah, that one got me. Right? So then our revenue function, the revenue generated when we sell for a price P, that's going to be P times this guy over here. 2,500 P plus 159,000. Okay. So now we got our quadratic function. That's what I was looking for. I was like, man. So then minus 2,500 P squared plus 159,000 times P. Okay. So then now we're back to the whole vertex thing. All right. Negative B over 2A. So that's going to be a negative 159,000 over 2 times a negative 2,500. So divided by 5,000. You can actually just knock off the trailing zeros. Siri, what's 159 divided by 5?
159 divided by 5 is 31.8.
Let's see, that's the X coordinate. So the revenue is going to be maximized when the price is $31.80. Okay. And then we can also identify the maximum. Let me see, what price should they charge for a quarterly subscription to maximize the revenue? $31.80. Okay. We didn't find the max revenue. We could. Okay. Can I paste? No. Yeah, let me see. Let's kind of recap that one. That one got me. But I think I was struggling because I wasn't like, first I was trying to jump straight to my revenue function, and I was kind of ignoring. So, let's kind of back up and just look at it one more time. So essentially they gave us two pieces of information, right? They said when we charge 30, we get 84,000 subscribers. If we charge $32, we'll get 79, right? So then we can find the equation of the line through this point, and what that's going to give us is the number of subscribers based on the price, right? So Q based on P. This should have been like Q of P right here. All of this should have been a P. And I kind of had it, but I kind of got it mixed up, right? So this is telling us the number of subscribers based on the price. So that should be a P there. Let's go ahead and make that change. Okay, number of subscribers based on the price. Okay, and then from there, Once we have the number of subscribers based on the price, then the revenue based on the price is going to be P times Q. Then we got our quadratic function. Then from there, it was, once we had our quadratic and it was opening downward, that means we have a maximum value. Then we use the vertex formula, and we got that it's going to be maximized when the price is $31.80. That one was interesting. That one actually made me think. Let's see, 31.80, and we got it there. Yeah. Okay, that was interesting. I kind of want to do another one of those. Let's see what else we have. I know we got more. Let's see, given the quadratic function, find the x and y intercepts. Okay, that's not too bad. Find the y-intercept and the x-intercept of this quadratic function. Let me see if there's nothing different, right? So I like to start with the y-intercept first, right? Oftentimes I feel like that's easier. So if we want to find the y-intercept, we set x equal to 0. Okay. So then that's going to be f of 0. It's going to be 3 times 0 squared plus 5 times 0 minus 2. So then the y-intercept is going to be 0, negative 2. Okay. Okay, so then for the x-intercept, we set y to 0 and solve. So then we're going to have 3x squared plus 5x minus 2 equal to 0. Now we could use the quadratic formula. We might be able to factor this guy. We're looking for two numbers that multiply to give us negative 6 and add to give us 5. Looks like it's going to be 6 and negative 1. Okay. So I'm going to use the box method to solve this guy, to factor this guy. In the upper left-hand corner goes our leading coefficient, which is this guy. Bottom right is our constant. And we did the AC method. We said 3 times negative 2 to give us negative 6. And so we got a positive 6 and a negative 1. So we're going to rewrite that 5x, so this guy, using the 6 and the negative 1. So we got a 6x and a negative 1x. Okay. So then if we focus on the 2 on the top, the greatest common factor there looks like it's a 3x. The 2 on the bottom, we can factor out a negative 1. The 2 on the left, we can factor out x. And the 2 on the right, it looks like we can factor out a positive 2. So then our claim is that the original factors into 3x minus 1 times x plus 2 equal to 0. So then from there, x equals a third or negative 2. So then we get 1/3 comma 0 or negative 2 comma 0. Okay. So the y-intercept, they got negative 2. X-intercept, yeah, I think we're good. So it looks like we can get the x-intercept, like if we get the quadratic in standard form, and then solve for x, and you can solve for x that way as well. So that's basically using the technique of completing a square, right? So find the x-intercept of this quadratic. Let me see, what does it say to get it in standard form? Rewrite it. Okay, so they basically solve for h and k and then use that to write it in standard form. Okay. So then our h is going to be a negative b over 2a. So that's going to be negative 4 over 2 times 2, which is negative 1. Then our k is going to be f of h. So that's going to be f of negative 1. 2 times negative 1 squared. Let me kind of move that part down. Plus 4 times negative 1 minus 4. It's going to be 2 minus 4 minus 4. Looks like it's a negative 6. So then the standard form of a quadratic, a times x minus h squared plus k. I think we have all three of those components. So then in standard form, our a is 2, our h is negative 1. So x minus negative 1 becomes x plus 1 squared. Our k is minus 6. So then if we want the x, now that we got it in this form, we can set this guy equal to 0 and solve. Add the 6. We'll get 2 times x plus 1 squared equals 6. Divide by 2. We get 3. Take the square root. Now when we take square root, we should introduce the plus or minus 3. And then subtract 1. X equals negative 1 plus or minus the square root of 3. Okay. I'll kind of keep working here. So that's it. Those are the exact results for our x-intercept. So we will have negative 1 minus the square root of 3, comma 0. And negative 1 plus the square root of 3, comma 0. All right. So that was basically what we did. We rewrote. We found out. The goal was to write the general form of the quadratic in standard form. So we went on and used our vertex formula. We found our h. We found our k, and we used the given a to write it in standard form. And then we set that function equal to 0 and solve for x. Negative 1 plus or minus the square root of 3. Okay, we're almost done. I know I got caught. You have to forgive me for getting caught up. I got hung up on it. I just, couldn't figure it out. So on the I don't know, on the ones I got wrong, but we still got to the bottom of it. So, I do want to work some more examples similar to that. I think we got what we have. Okay, so a ball is thrown upward from the top of a 40 foot high building at a speed of 80 feet per second. The ball's height above ground can be modeled by this guy. When does the ball reach maximum height? So that should occur at the vertex. Notice the highest power is the power of 2, so we have a parabola. The leading coefficient is negative, so the parabola opens downward. So we should have a maximum that should occur at the vertex. So we can use our vertex formula. H equals negative b over 2a. So that's going to be negative 80 over 2 times negative 16. So that's 32. 40 over 16, you can divide by 4. It's 20 over 8. Looks like we can divide by 4 again. 5 over 2. So I think both of those are divisible by 16. Siri, what's 80 divided by 16?
80 divided by 60 is approximately 1.3333.
Siri, what's 80 divided by 16?
80 divided by 16 is 5.
Okay, yeah, I think we're good. So they were both divisible by 16. So we have the x coordinate of our vertex. And I think that's all we needed for part A. Because it says, when does the ball reach the maximum height? That's going to occur when our time is 2.5 minutes. Or feet per second, so 2.5 seconds. After 2.5 seconds. Okay, that was part A. Part B, what is the maximum height? So then they're basically asking for the K, which is going to be equal to f of h. So that's going to be f of 2.5. I think I'm going to just try to use my calculator. Siri, what's negative 16 times 2.5 times 2.5 plus 80 times 2.5 plus 40?
I found some web results.
Darn.
I can show them if you ask again from your iPhone.
I'm going to try this one more time. Siri, what's negative 16 times 2.5 times 2.5 plus 80 times 2.5 plus 40?
Negative 16 times 2.5 times 2.5 plus 80 times 2.5 plus 40 is 140.
So we're saying that it reaches a maximum height of 140 feet. And then when does the ball hit the ground? So when the height is 0, so we want to set the original equal to 0 and solve. I might need some space. Okay, yeah, let's duplicate this guy and clear. So for C, we want to set the original to 0 and solve. We got this negative 16t squared plus 80t plus 40. We want to set that equal to 0. It looks like we can at least divide. I want to divide both sides by negative 4. Let's divide both sides. Let's factor out a negative 4. I'm just going to divide both sides by negative 4. That's going to give us 4t squared minus 20t minus 10 equals 0. Okay. And then it looks like we can divide by, we can factor out a 2. So I guess we could have factored out 8. Yep, but that's fine. We're going to go ahead and factor out 2 from everything. So now we'll have 2t squared minus 10t minus 5 equals 0. Okay. So I think we can use the box method. We're looking for two numbers that multiply it. Nope. Yeah. Nope. 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 I was going to say two numbers that multiply to give us negative 10. But we can use that same technique that we used a moment ago where we write it in standard form. Now I did some manipulations. Let me see. Negative b over 2a. So if I'm gonna backtrack because I'm leery about using this form to proceed because we kind of manipulated the a already. So I'm going to work with my original numbers just to minimize my chances of error. And I'm going to get this in standard form like we did a moment ago. So our h is going to be, did we find this already? We found all this, right? So we have our h and our k. So 2.5 and 140. So we can actually use that. Our h was 2.5, our k was 140, and our a is negative 16. Okay. So in standard form, here, let me do it. I mean, that's fine. A times t minus h squared plus k. All right, so let's plug that information in. So then h of t, we're just writing this in standard form. Our a is negative 16. T, our h is 2.5, so we're going to say minus 2.5 squared plus 140. Okay. So now that we have it in this form, we're going to go ahead and set this guy equal to 0. All right, because we want to know when is the height 0. So now that one's much easier to solve. We can subtract the 140 on both sides. We'll get the negative 16 t minus 2.5 squared equals a negative 140. Divide both sides by negative 16 squared. Siri, what's 140 divided by 16?
140 divided by 16 is 8.75.
Okay, we'll go with it. Okay. We need to take the square root and add. Ultimately, we get t equals 2.5 plus or minus the square root of this 8.75. Okay. Now 2 minus the square root might be, I think it's going to be outside of our domain. You know, it's going to be, it should be negative. Siri, what's 2.5 minus the square root of 8.75?
5 minus square root of 8.75 is approximately 2.0419.
Siri, what's 2.5 minus the square root of 8.75?
5 minus square root.
She is not getting that first number. That's so annoying.
2.1715.
Let me try one other thing. Siri, what's a negative square root of 8.75 plus 2.5?
I found some web results.
All right, I got.
Show you if you ask again for
I
your
don't.
iPhone.
I don't really want to use this other calculator. It's kind of a hassle. I guess I'll bring it up. So I'll put it here. Let me just close. Okay, let's go like this. Reload and refresh. Because Siri doesn't want to hear the 2 for whatever reasons. Let's see. So we got 2.5 minus the square root 8.75. Okay. So we're getting a negative result, right? So we're not going to use that one. That's outside of our domain or outside the context of this question. So then we're going to just evaluate when it's a plus. Okay. So after 5.46 seconds. Okay. And they ended up using the quadratic formula, which is fine. Mm-hmm. 5 point, yeah. So I think we got the same thing. Okay, that was an adventure, right? So we did kind of get stuck on one, but we did get to the bottom of it, and that does happen, right? And I like, obviously I could redo the video, but you know, I want you all to experience, like, sometimes, you just have to, sometimes you have to kind of like think through it. Not that I got it, but then you do your research, you kind of ask around, ask the tutor, ask me. And between your classmates, the tutors, and me, we'll be able to get to the bottom of it. Even if I don't know it directly, I can like dig and do some research and figure it out, right? And so I like for you all to see me to process. Most times I'm able to figure these out. Occasionally I'm not, right? So, and I intentionally left that in there, just so you can see some of the process. And we weren't far off, and like the actual thing was close to what we were experiencing. We were just mixing up what we should have been looking for and the units and things of that nature, right? They gave us 2 ordered pairs. We were finding the equation of the line through the point. We just didn't realize it. And then when we realized that we found the equation of the line, and then we were able to we had to put our units proper and then find the revenue function, which was the price times that Q. And then we got our quadratic. Then from the quadratic, we were able to identify the vertex, that it was a maximum, stuff of this nature, right? So I think that experience is important. That's why I left it in there. I could redo this and remove that, but I'm not going to. All right, so with that, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.